This video was produced in 1992 by Nordstrom Valves Incorporated. In 2002, Flowserve Corporation acquired Nordstrom Valves through the purchase of the Flow Control Division of Invensis plc. At that time, Nordstrom Valves, located in Sulphur Springs, Texas, was renamed Flowserve Sulphur Springs Operations. This facility continues to manufacture the same high-quality product, known today as Flowserve Nordstrom Valves. This video continues to address many of the lubricated plug valve and sealant injection products manufactured by Flowserve Sulphur Springs Operations. However, some product may have been modified or new product introduced that is not included. Flowserve Corporation reserves the right to make product modifications that may contradict the contents of this video without notification to its holders. This video is intended as a guide for educational and training purposes only. If the Flowserve Nordstrom Valves product you require troubleshooting and maintenance information on is not included in this video, or if anything in this video is unclear to you, please contact your local Flowserve Nordstrom Valves representative for assistance. Before using or working on any Flowserve Nordstrom valve or other product, the viewer should review and fully comply with the Flowserve Nordstrom maintenance and instruction manuals prepared for each Flowserve Nordstrom valve, and to its warning labels, and with the viewer's company safety procedures. Flowserve Corporation and its associates cannot be held responsible for any information that is found to be inaccurate or incomplete, and are in no way responsible for damage to property or for personal injury or death which may result through the use or misuse of any Flowserve Nordstrom product publication, audio or visual aids.
Nordstrom Valves Incorporated is a manufacturer of high-quality iron and steel plug valves. With more than 70 million plug valves in the field, and with experience covering more than 70 years, Nordstrom is recognized as today's premier plug valve manufacturer. Nordstrom valves are used in a wide range of applications, such as oil and natural gas production and transmission, and general industrial service. This video takes a comprehensive look at Nordstrom HyperSeal and Dynamic Balance high-pressure plug valve design and maintenance. After you have viewed this video, you'll be able to identify Nordstrom HyperSeal and Dynamic Balance lubricated steel plug valves in the field. You'll be able to operate and maintain the two main tools used to service Nordstrom valves, the Nordstrom 400D handgun and the Nordstrom Hypergun. You'll be able to identify and describe in detail the specific differences between HyperSeal and Dynamic Balance valves. You will learn how to use the Nordstrom 400D handgun and the Hypergun as diagnostic tools to identify operation and maintenance problems that may occur in Nordstrom valves. You'll also learn how to use them to confirm proper valve operation. Finally, you'll receive detailed instructions on how to solve operation and maintenance problems for all Nordstrom HyperSeal and Dynamic Balance valves currently in use. Here is a brief introduction to these valves. Each style will be examined in greater detail later in this video. This is the Nordstrom HyperSeal valve design. And this is the Dynamic Balance valve design. Each of these valves has a tapered plug that fits into a matching seat. The plug rotates through a quarter turn to permit or block flow through the valve. You probably know that these valves are called lubricated plug valves because a thin layer of sealant between the seat and the plug provides a fluid-tight seal. Periodically, more sealant must be injected into the valve to replenish the supply. There's a physical law that describes how this pressurized sealant acts in the valve. It's called Pascal's law. Pascal's law states that a unit pressure applied to the fluid contained in a sealed vessel is transmitted uniformly to all areas of the confining surface of the fluid with undiminished force, thus multiplying the force many times. In other words, if a force is applied to a fluid in a confined area, the force will be transmitted equally to every other area of the confined fluid. This means a small force applied to a small area of a confined fluid is transmitted and multiplied, so it applies a larger force to a larger area of the same fluid. For example, suppose 100 pounds of force is applied to a piston attached to a cylinder. If the piston has an area of 1 square inch, it creates a pressure in the cylinder of 100 pounds per square inch. Now, suppose there's another piston attached to the cylinder. The entire surface of that piston is subject to the pressure of 100 pounds per square inch created by the force on the small piston. If it has an area of 10 square inches, then by Pascal's law, the pressure on each square inch produces a force of 100 pounds. Since the area of the piston is 10 square inches, the total force produced on the piston is 1,000 pounds. Using Pascal's law, we can multiply the effect of a small force to generate useful hydraulic forces in sealant injection equipment and in valves. Sealant injection equipment uses a piston to apply pressure to the sealant, and that pressure is transmitted uniformly to all surfaces the sealant contacts. Sealant grooves in the plug and body transmit pressure from the sealant fitting to the bottom chamber. In the bottom chamber, the pressure is applied uniformly to the bottom of the plug. While flow resistance reduces the pressure by the time it gets to the plug, the large area of the plug bottom multiplies the pressure, producing a strong upward force on the plug. The force can be powerful enough to move the plug off its seat during relubrication, making the valve easy to operate. The movement is exaggerated here for illustration purposes. When the plug moves off its seat, sealant can flow into the taper between the plug and body. The sealant can come from both the bottom chamber and from the sealant grooves. The grooves also help renew the sealant film whenever the plug is turned. Sealant injection ensures a drop-tight seal within the valve. The seal is formed by the sealant captured as the plug moves back into the seat. Whenever possible, it's very important to turn the plug back and forth to evenly distribute the sealant over the seating surfaces of the plug and valve body. This should be done whenever a valve is injected with sealant and periodically between injections. Rotating the plug also helps combat corrosion around the valve stem and ensures proper operation of the valve. Regular sealant injection and rotation or exercise of the plug are essential to long valve life and optimum performance. Most valve problems can be directly attributed to failure to regularly inject sealant or exercise a valve. The principles of Pascal's law also enable us to troubleshoot valves when we inject sealant. By observing the pressure it takes to inject sealant, we can infer a valve's condition. The bulk of this presentation will show how this works with high-pressure plug valves. For detailed information about the operation and maintenance of the Nordstrom 400D handgun and the Nordstrom hypergun, please consult the Nordstrom Sealant and Sealant Equipment video. As you know, each valve style requires different service and maintenance techniques. Before you can properly service your valves, you need to be able to identify which design and style of Nordstrom valve you're working with, so you can apply the correct service methods. Let's review each valve design and style individually. There have been two basic designs: hyperseal valves and dynamic balance valves. Both designs are downstream seating valves. The first Nordstrom valve design to consider is the hyperseal valve. The hyperseal valve is a steel valve featuring an inverted plug. The cover is located at the opposite end from the operating mechanism. Also, the sealant fitting is located in the stem. The hyperseal valve was manufactured from the early 1930s until the late 1970s. A large number of these valves are still in service. The hyperseal valve has 5 main parts. First, the inverted plug, the valve body, the stem, the valve cover, and an adjustment mechanism. As you know, sealant is also an essential part of this and every type of Nordstrom lubricated plug valve. Most hyperseal valves have a threaded stem with 2 ball check valves located below the sealant fitting. These check valves prevent line pressure from reaching the sealant fitting. Also, the hyperseal valve features a 3-piece drivetrain. These pieces are the plug, the equalizer, and the stem. The equalizer acts as a floating union between the stem and the plug. This design allows freer movement of the plug in the taper. The Nordstrom Dynamic Balance Valve has been in production since 1976. Any Nordstrom high-pressure steel valve with a sealant fitting located on the side of the valve is a dynamic balance valve. Again, there are 5 main parts to this valve. First, the inverted plug, the valve body, the stem, the valve cover, and an adjustment mechanism at the bottom of the plug. Once again, sealant is also an essential element. The inverted plug is pressure balanced. This means that the passages within the plug equalize line pressure at each end of the plug. If the valve has been properly adjusted, this design will effectively prevent taper lock from occurring. Also, the dynamic balance valve features a threadless anti-blowout stem. This stem eliminates some of the operational problems often found in the older hyperseal valve design. The dynamic balance valve features the same type 3-piece drivetrain found in the hyperseal valve: the plug, the equalizer, and the stem. As in the hyperseal valve, the equalizer acts as a floating union between the stem and the plug, allowing free movement of the plug in the taper. By learning to identify Nordstrom high-pressure steel valves, you'll be able to determine the exact valves you're servicing in the field. Once you know the specific style of valve, you can use the correct service and maintenance procedures for that particular valve. The Nordstrom Hypergun or 400D handgun can be employed as a diagnostic tool to help you identify the condition of and maintenance requirements for the Nordstrom valves you service. By monitoring the sealant equipment gauge as you inject sealant into a valve, you can ascertain the valve's operational status. There are 4 gauge scenarios that can help you discover valve seat leakage problems, operation difficulties, and other problems or adverse conditions. Once you've identified the applicable gauge scenario, you can apply the appropriate maintenance procedures to ensure your valves are operating at their peak. First, you need to understand the 4 basic gauge scenarios and the information each provides. Scenario number 1 is when the gauge does not indicate a pressure increase above the initial pressure required to inject sealant into the valve. Assuming the 400D handgun or hypergun is operating correctly, there are 2 possible problems. The sealant system is not full, or the seat is leaking. Leaking may be caused by too loose an adjustment or damage to the valve's seating area. Scenario number 2 is when the gauge indicates a gradual increase in pressure as sealant is injected until an initial plateau is reached. Then at some point the pressure increases to a higher plateau and then abruptly falls back to a lower level. This scenario shows that the valve is receiving sealant properly, the valve has filled, and the plug has moved off the seat. Even though this scenario shows that the plug has moved off the seat, it is still possible that the valve may be difficult to operate. This may be caused by too tight an adjustment, stem corrosion, or gearing problems on gear-operated valves. Scenario number 3 is very much like scenario 2, except the sealant pressure gauge reaches a plateau and remains at that point as the handgun or hypergun is operated, even after you've injected more than enough sealant to fill the valve. This scenario signals one of two quite different conditions. If the plug is not locked in the body taper, then the plug may be moved and the additional sealant is simply bypassing the plug. This is normal and indicative of a properly maintained, well-pressurized valve. However, if the plug is locked in the taper and cannot be operated, this indicates that the plug or valve body may be damaged and sealant is bypassing the sealing surfaces. In scenario 3, it is also possible for the valve to be difficult to operate. The likely causes are the same as with scenario 2: too tight an adjustment, stem corrosion, or gearing problems on gear-operated valves. In the fourth scenario, the gauge indicates a continual rise in pressure as sealant is injected, but never indicates a pressure decrease. This scenario indicates three possible problems. The valve sealant fitting is faulty, the sealant system is blocked, or the plug has seized in the body taper. Those are the 4 gauge scenarios you may encounter when using the Nordstrom 400D handgun or hypergun to service your valves. Other problems that might occur outside of these 4 scenarios include seat leakage or non-compressible fluid trapped in the plug with the valve in the closed position. If a non-compressible fluid is trapped in the center cavity of the plug when the valve is in the closed position, injecting sealant at high pressures or high volumes can cause the plug to lock in place. This can also cause the cover bolts to yield, thus producing cover leakage. The following sections of this video will examine in detail the specific maintenance steps you need to remedy any adverse conditions identified by each gauge scenario. Let's first examine scenario number 1. In that scenario, the gauge does not indicate a pressure increase above the initial pressure required to inject sealant into the valve. If the sealant injection device is operating properly, there may be a problem with the valve. The most likely cause of this scenario is seat leakage. The first thing you need to do is to ensure that the valve sealant system is full. Continue to inject sealant into the valve. When the valve is full of sealant, you should see a pressure increase on the gauge. Through your experience in the field, you should have a general idea of the amount of sealant you need to inject to fill a given size Nordstrom high-pressure steel valve. If an increase in pressure is not obtained after a sufficient amount of sealant has been injected, either the valve may be adjusted too loosely or the valve's sealing surface may be damaged. On hyperseal valves, examine the plug adjusting screw cap. If the tack weld between the screw cap and the cover of the valve has been broken, it's possible that the valve has been readjusted since it was set at the factory. It may need further adjustment. On dynamic balance valves, first remove the plug adjusting cover. Then check the plug adjusting screw, which has been backed out here for visual purposes. If the mark on the screw does not align with the mark on the valve cover, the factory adjustment has been changed. The valve may need to be readjusted. If you need to tighten the plug adjusting screw on either design valve, use the appropriate wrench. Operate the valve back and forth through its 90-degree operating range and simultaneously tighten the plug adjusting screw. This action will help disperse the sealant you just injected into the valve. If operating conditions prevent rotating the plug completely through its 90-degree operating range, you can rotate the plug through a 30-degree arc to disperse the sealant. Continue to tighten the plug adjustment screw until a noticeable torque increase makes it harder to turn. This will indicate that you have metal-to-metal contact between the plug and the valve seat. Be careful not to tighten the screw too much, or you'll lock the plug in the body taper. Now loosen the screw 1/8 turn and inject new sealant into the valve using the hypergun or 400D handgun. You should receive a higher pressure reading on the gauge. When you've completed any plug adjustment procedures, always replace the cap or cover. If a non-compressible fluid is trapped in the center cavity of the plug when the valve is in the closed position, injecting sealant at high pressures or high volumes can cause the plug to lock in place. This can also cause the cover bolts to yield, thus producing cover leakage. If you still don't get a pressure increase on the gauge, you need to adjust the valve further. Operate the valve back and forth through its 90-degree operating range, and simultaneously tighten the plug adjusting screw to help disperse the sealant. Once again, inject sealant into the valve, and check the gauge for a pressure increase. If you still do not receive a pressure increase, the plug or body seating surface may be damaged. A damaged area on the plug or body allows sealant to be injected directly into the piping system, and the sealant cannot generate pressure to force the plug off its seat. A possible solution to this problem is to rotate the plug 180 degrees. This procedure will place the undamaged upstream plug sealing surface to the downstream sealing surface of the valve body. The plugs on both hyperseal and dynamic balance valves can be rotated in line and under pressure. The procedures are different depending on whether the valve is wrench or gear operated. With wrench operated dynamic balance valves, completely remove the retaining ring and indicator stop collar. For wrench operated hyperseal valves, loosen the set screw and lift the indicator stop so that it clears the stop mechanism. Then loosen the plug adjusting screw 1/2 turn. Now rotate the stem 180 degrees counterclockwise. This will place the upstream plug sealing surface in contact with the downstream sealing surface of the valve body. Retighten the plug adjusting screw and replace the stop collar. On gear-operated valves, the valve must be fully open to rotate the plug 180 degrees. Do not proceed without confirming that this is safe. If it is, remove the gear housing bolting. Next, turn the gearing hand wheel clockwise. The housing will move counterclockwise. Be careful not to damage the gasket while rotating the gearing. Turn the wheel until the housing bolt holes align with the next hole in the gear flange. Then replace 2 housing bolts. Next, turn the hand wheel counterclockwise until the gear segment contacts the valve stop. Remove the 2 bolts and repeat the process until the housing has been turned 180 degrees. Then check the gasket and replace all the bolting. If rotating the plug 180 degrees does not remedy the problem, there may be damage to the body sealing surface. The entire valve should be replaced. Contact Nordstrom's customer service department to locate your nearest Nordstrom valve distributor. Now let's examine scenario number 2. That's where the gauge indicates a gradual increase in pressure to an initial plateau as sealant is injected. Then, at some point, the pressure increases to a higher plateau, falling back with each stroke of the injection equipment. In this case, the plug has moved off its seat and the valve is receiving sealant properly. To confirm that the plug has indeed moved off its taper, continually loosen and tighten the plug adjusting screw slightly as you inject sealant into the valve. When the screw becomes difficult to move, the plug is off the taper. If the valve is difficult to operate, even though the plug is moved off its seat, one of the following problems may exist. The plug adjustment is too tight. There is stem corrosion, particularly on wrench-operated valves. Or there are gearing problems on gear-operated valves. On hyperseal valves only, old stem packing can make the valve hard to operate. First, check to see if the plug adjustment is too tight. On both hyperseal valves and dynamic balance valves, simply loosen the plug adjusting screw 1/8 turn. Then inject sealant into the valve. You should now be able to operate the valve. If not, check for possible stem corrosion. The procedures for remedying the situation are slightly different for the two valve styles. For hyperseal valves, first remove the indicator stop collar. Then inspect the stem for visible signs of corrosion. If corrosion exists, dam the area around the stem with heavy grease or Nordstrom stick sealant. Next, introduce penetrating oil into the stem-to-body joint. Allow the penetrating oil to saturate the stem-to-body joint for a minimum of 24 hours. Then replace the indicator stop collar. Once you have reassembled the stop mechanism and checked to make sure it is now operable, inject sealant using the Hypergun or 400D handgun. For dynamic balance valves, first remove the retaining ring and the indicator stop collar. Then inspect the stem weather seal for visible signs of damage or corrosion in the stem or gland. If the weather seal is damaged, replace it. If any corrosion exists, dam the area around the stem with heavy grease or Nordstrom stick sealant. Next, introduce penetrating oil into the stem-to-gland joint. Allow the penetrating oil to saturate the stem-to-gland joint for a minimum of 24 hours. Replace the stop collar and retaining ring. And then operate the valve to make sure the penetrating oil reaches the stem-to-gland joint. If the valve is now operable, remove the retaining ring and stop collar again. And coat the area under the weather seal with lithium-based grease. Then reassemble the weather seal, stop collar, and retaining ring. Once you've reassembled the stop mechanism, inject sealant using the Hypergun or 400D handgun. If penetrating oil does not free the valve, you need to clean the inside surfaces of the gland and stem. This procedure must be performed only after all pressure has been removed from the line and the valve. To attempt to do this while the line and valve are under pressure could result in property damage or personal injury or death. For detailed instructions on this procedure, consult the Nordstrom Maintenance Manual. If the valve is gear operated, you should check to see if gearing problems are preventing the valve from operating. If you're working with a hyperseal valve, the first step is to loosen the set screw located in the side of the external indicator stop. From this point on, the procedures are similar for both dynamic balance, shown here, and hyperseal gear-operated valves. Remove the indicator. Then remove the gearing and the segment key. Now reinstall the gearing and attempt to operate the gearing. If the gearing is difficult to operate, the problem is in the gearing. Remove and disassemble the gearing. Inspect the gear segment and the worm gear for excessive wear or damage. Also, rotate the worm shaft to see if the bearings may be binding. Replace any parts as necessary, and ensure that the gearing operates properly before reassembling the valve. With hyperseal valves, old stem packing may cause valve operation difficulties. Inspection and replacement of stem packing in hyperseal valves requires that all pressure be removed from the line and the valve. To attempt to do this while the line and valve are under pressure could result in property damage or personal injury or death. For detailed instructions on this procedure, consult the Nordstrom Maintenance Manual. If these procedures fail to permit easy operation of the valve, contact Nordstrom Valves Customer Service. Now consider scenario number 3, where the sealant pressure gauge reaches a plateau and remains at that point as the handgun or hypergun is operated, even after you've injected more than enough sealant to fill the valve. This scenario may mean one of two things. First, it may indicate that the plug is not locked in the body taper and that the excess sealant being injected is simply bypassing the plug. This is normal and indicative of a well-maintained and pressurized valve. However, this scenario may also mean that the plug is in the taper and the plug or body is damaged, thus causing sealant to bypass the plug sealing surface. Seat leakage is a possible cause. Rotating the plug 180 degrees may remedy this problem. Also in this scenario, each style valve may be difficult to operate. As before, the plug adjustment is too tight, stem corrosion is present in wrench-operated valves, or there are gearing problems on gear-operated valves. Or with hyperseal valves, the stem packing needs to be replaced. As before, first check plug adjustment, then look for stem corrosion or gearing problems. If these procedures fail to permit easy operation of the valve, contact your Nordstrom Valves sales representative. In the last scenario, number 4, the gauge indicates a continual rise in pressure as sealant is injected, but never indicates a pressure decrease. In this scenario, there are 3 probable causes: a faulty sealant fitting, a blocked sealant system, or a seized plug. Blockage problems are most commonly associated with these operation difficulties. However, a lack of sealant in the primary seal area of the valve may still allow seat leakage. This scenario can also be caused by fluid trapped in the plug with the valve in the closed position. Continual injection of sealant may cause cover leakage. First, you should examine the sealant fitting to determine whether it's operating properly. The procedures are the same for both hyperseal and dynamic balance valves. In this procedure, make sure the sealant fitting is always pointing away from your body. This will help prevent injury in the event there is any pressure behind the fitting. Also, be sure to wear eye protection. Begin by checking for pressure behind the sealant fitting. Depress the center button in the sealant fitting with a small punch or screwdriver. If fresh sealant is released through the sealant fitting center button, the sealant fitting is accepting sealant and operating properly. If continual pressure is present in the sealant system, leakage from the line may be pressurizing the sealant system. No repairs can be made in line under pressure. To do so could result in property damage or personal injury or death. Consult the Nordstrom Maintenance Manual for detailed procedures. If the center button of the sealant fitting cannot be depressed, the sealant fitting is probably faulty. To test the fitting, first carefully unscrew the sealant fitting. While you're unscrewing the fitting, attempt to move it back and forth to check for sealant system pressure below the fitting. If the sealant fitting cannot be moved back and forth easily, pressure may exist below the sealant fitting. Again, no repairs can be made in line under pressure. To do so could result in property damage or personal injury or death. Consult the Nordstrom Maintenance Manual for instructions. If there is no pressure behind the sealant fitting, remove it. Then attach it to the handgun or hypergun. And inject sealant into the sealant fitting to flush any trapped debris. If the fitting will not accept the injected sealant, the fitting is faulty and it will have to be replaced with a new one. If the fitting does accept injected sealant, it's functioning properly. Replace the faulty sealant fitting or reinstall the properly functioning fitting. Now inject sealant into the valve. The valve should accept sealant, and the gauge should register a pressure increase followed by a pressure decrease once the valve fills completely. If the valve still will not accept sealant, or if the gauge still indicates a continual rise of pressure, the sealant system may be blocked. You'll need to purge the entire sealant system to eliminate the blockage. The procedures for purging the sealant system are the same for both hyperseal and dynamic balance valves. First, remove the sealant fitting from the valve, using the same procedures you just learned to test the fitting for proper operation. Set the sealant fitting aside for the moment. Next, remove the sealant from the Hypergun or 400D handgun and replace it with Nordstrom VPX Valve Purge, a non-hazardous formulation designed to provide the maximum cleaning and solvency necessary to remove hardened sealant or debris from the sealant system. Once the VPX Valve Purge is in the gun, operate the gun to clear the hose and button head coupler of sealant. Attach the gun's giant button head coupler to the detached sealant fitting and inject VPX Valve Purge. Then remove the sealant fitting from the button head coupler. Using a screwdriver or similar object, remove any sealant remaining below the sealant fitting. Be careful not to introduce any foreign material into the sealant, or damage to internal parts or blockage of the sealant system could occur. Now reinstall the sealant fitting. Reattach the button head coupler to the sealant fitting and inject VPX Valve Purge into the valve. Watch the gauge as you inject VPX Valve Purge. If the gauge indicates a pressure increase as you inject VPX Valve Purge, but never indicates a pressure decrease, the sealant system may be blocked to the point that valve purge will not be effective, or the valve may be damaged. The valve may require complete disassembly for cleaning, or it may need to be replaced. If the gauge indicates a pressure increase followed at some point by a pressure decrease, continue to inject VPX Valve Purge until a significant amount has been introduced. The amount of purge required will vary per valve. Allow the purge to remain in the valve for a minimum of 24 hours to dissolve the blockage. Do not leave purge in the Hypergun or 400D handgun for more than 8 hours, because solvents in the purge may damage parts such as O-rings. Remove the purge from the gun and reload it with sealant. Attach a spare sealant fitting to the giant button head coupler and operate the gun until sealant flows from the fitting. Once the purge has dissolved or softened the blockage, operate the valve a few times in order to free the sealant system. Remove the sealant from the gun and reload it with VPX Valve Purge. Now inject purge into the valve again. The valve should accept the purge quicker than before, as indicated by a faster pressure reduction on the handgun or hypergun gauge. Remove the VPX Valve Purge from the handgun or hypergun and replace it with sealant. Finally, inject sealant into the valve. A third possible cause of the fourth scenario is a plug that has seized in the body taper. You'll need to adjust the plug mechanism to free the plug. The procedures are the same for both hyperseal and dynamic balance valves. First, remove the adjusting screw cover. Use a wrench to turn the plug adjusting screw 1/8 turn. Using the handgun or hypergun, inject sealant into the valve as you move the plug adjusting screw back and forth until the plug has moved off the body taper. Once the plug has lifted from the taper, retighten the plug adjustment screw until it becomes difficult to operate the valve. Then loosen the screw back 1/8 turn. Finally, fill the valve with sealant. You should now be able to operate the valve. You may occasionally encounter other leakage problems with Nordstrom Hyperseal and dynamic balance valves. These problems include bottom cover leakage, external leakage around the stem, and check valve leakage. Bottom cover leakage is usually simple to cure. Using a wrench, loosen the adjusting screw 1/4 turn. Then retorque the cover bolting. Finally, retighten the plug adjustment screw. If the cover still leaks after you've tightened the plug adjusting screw and cover bolts, you'll need to examine the gaskets and diaphragms and replace any parts that are damaged. Gasket and diaphragm examination and replacement must be performed only after line pressure has been removed from the valve. To do so could result in property damage or personal injury or death. Consult the Nordstrom Maintenance Manual for complete instructions. The procedures for curing any external leakage from around the stem are different for the hyperseal valve and the dynamic balance valve. For the hyperseal valve, first remove the Allen screw from the stem packing injector. Then insert Nordstrom 909 stem packing. Next, replace the Allen screw and turn it to inject the stem packing. Repeat these 3 steps until the leaking has stopped, or the packing injector will not accept any more stem packing. Fixing external stem leakage on dynamic balance valves requires that the valve be depressurized. Consult Nordstrom's Maintenance Manual for complete instructions. Check valve leakage is sometimes the problem. It lets line fluid reach the sealant fitting. To identify check valve leakage, depress the sealant fitting button and look for line fluid that has bypassed the check valve. Sometimes the fluid will leak through the sealant fitting. The first step to correct the problem is to inject sealant into the valve to flush any debris from the check valve seat. If flushing the check valve does not stop the leakage, the check valve should be replaced. This requires removing line pressure from the valve. Attempting to replace the check valve when the line is under pressure could result in property damage or personal injury or death. Consult Nordstrom's Maintenance Manual for complete instructions. In the event these procedures have not corrected a specific problem with a Nordstrom hyperseal or dynamic balance valve, please contact Nordstrom for detailed information about on-site repairs performed by Nordstrom Service Department personnel. Let's review what you've learned as a result of watching this video. You can now identify in both general and detailed terms the various designs and styles of Nordstrom hyperseal and dynamic balance lubricated steel plug valves. And you can use the Nordstrom 400D handgun and hypergun to service, diagnose, and maintain Nordstrom valves in the field.
This video was produced in 1992 by Nordstrom Valves Incorporated. In 2002, Flowserve Corporation acquired Nordstrom Valves through the purchase of the Flow Control Division of Invencis plc. At that time, Nordstrom Valves, located in Sulphur Springs, Texas, was renamed Flowserve Sulphur Springs Operations. This facility continues to manufacture the same high-quality product, known today as Flowserve Nordstrom Valves. This video continues to address many of the lubricated plug valve and sealant injection products manufactured by Flowserve Sulphur Springs Operations. However, some product may have been modified or new product introduced that is not included. Flowserve Corporation reserves the right to make product modifications that may contradict the contents of this video without notification to its holders. This video is intended as a guide for educational and training purposes only. If the Flowserve Nordstrom Valves product you require troubleshooting and maintenance information on is not included in this video, or if anything in this video is unclear to you, please contact your local Flowserve Nordstrom Valves representative for assistance. Before using or working on any Flowserve Nordstrom valve or other product, the viewer should review and fully comply with the Flowserve Nordstrom maintenance and instruction manuals prepared for each Flowserve Nordstrom valve, and to its warning labels, and with the viewer's company safety procedures. Flowserve Corporation and its associates cannot be held responsible for any information that is found to be inaccurate or incomplete, and are in no way responsible for damage to property or for personal injury or death which may result through the use or misuse of any Flowserve Nordstrom product publication, audio or visual aids.